All right, guys. So what I want to do now is just talk about some of the basic statistics functions in R. It's just the next section. To me, R's visualizations beat Excel any day of the week. The problem is it's not their base visualization. For more advanced visualizations, you guys should look into the ggplot and ggplot2 functions. You should talk about that a lot more in your data viz classes. I'll talk about it a little bit as we get more advanced into R. I'll give you guys some resources for that type of stuff. But for right now, what I want to do is I just want to talk to you about the base visualizations just to show you how to make histograms and things like that. The first thing you can do, we're just going to attach the data set just to make it easier. Typically, I may or may not attach things. Some functions or some types of analyses you don't need to attach. When you're doing basic visuals and things like that, it's useful too, I'll say that, and you'll see why. We're still going to use the Big Mac 2003 data set. You'll see I like it pretty well for just intro stuff, intro discussions. It's the idea that we're going to attach the data set, and then we're just going to run a histogram, okay? Histogram functions hist, and I'm going to do it of teacher's net income, and we're going to do it in thousands. So you see I put a label on the main, and you'll see here's where the label pops up. And as you can start to see, okay, now it becomes problematic. Now you can add color and you can do things like that. A lot of times the visualizations that pop up in our base are just to get intuition for the analysts themselves. If you're going to do stuff that you need to reproduce and need to hand to other people, take it to Tableau. Use Shiny. Use something like that. Use ggplot, which has a lot more complex feel to it. So the entire idea of what you need to do is you need to go in and be able to do this. Now, in histogram, we know if we change the number of breaks, it changes the visual that it gives us. So if I change the number of breaks, here's what I start to see. Now you start to see a peak. Looks like it's really weighted down here between 0 and 5. And then you start to see a little bit of a right skew come to it. Okay? Now, a lot of stats professors may tell you, no, there's only one histogram. I completely disagree, guys. You should be able to show multiple plots and multiple histograms just to give people a feel for what their data looks like. If we look at it on the default in R, you see this looks completely left skewed and it looks like it's an exponential decrease. We look at it with 15 breaks. You see maybe that's not the case. There's a peak here between 0 and 5, and then it really starts to come out. If you just look at the difference in the bins, it combines 0 to 10 and then 10 to 20. If you come over here and look at it again, if we break this up by 5s, you see why that first bar is so big, but you also see it's between 20 and 25 that really lends itself to the second peak. So there's a lot of things going on here that you need to think about. You can also see there's a long right tail. You guys know what we call that, right? It talks about the skew. Now, long right tail means it's skewed. Long left tail again means it's skewed as well. So it's not a symmetric. It's not anything like that. Now, if we look at a box plot, the whole idea of a box plot is what it's going to do is it's going to give us a breakdown of the quantiles. Quantiles of the data, remember, it's 25%. So 25% falls below the bottom line. 75% falls above that line. And here's times 2. The 75th percentile plus 2 times the interquartile range, or 1.5 times the interquartile range, depending on what you believe the outlier rule is. Interquartile range just means the 75th percentile minus the 25th percentile. Okay, so it's a definition of spread. And this is all the stuff you talked about in the intro stats class. But when you see things like this, it's a good way to visualize outliers. Basically what it says based on the IQR rule, here are 2 outliers that show up. Now, visualizations are great, and it's how we communicate data, but for a statistics point of view and from a statistician point of view, visuals can give us intuition about where to look, but we also need to be able to calculate the statistics we need to know. So basically the first one I want to teach you is summary, just because it shows you what's going on in your data. If I run summary Big Mac 2003, what it's going to do is it's going to give me the 5-number summary. Min, first quartile, median, third quartile, max, plus the mean. So there's 6 numbers here for every variable. So here's the summary of Big Macs, bread, all these different things. Now, typically what I look for when I'm looking at this, I'm looking to see if a distribution is symmetric. And if a symmetric distribution has the property where the mean and the median are almost exactly the same. Truly symmetric distributions, they'll be equal. Kind of quasi-symmetric distributions, they'll be close to each other. So look at tax rate, for instance. If I just do hist tax rate, Look at it. It's really, really close to symmetric. Now, you see it lean a little bit, but not as bad as other things. I want to show you guys something else just real cool about RStudio. If I do hist, bread, and hit tab, it's going to give me all these things that start with BR. And you can go through and find what you need. The other thing you could do is inside a function, hit tab, and it's going to tell you what the arguments are. So you can say X, a vector of values. You say X equals bread. And it's going to come up with a histogram of bread. So there's a lot of different things you can do. Again, you can specify main in the plots. If I just want to calculate the mean of a variable, which is what we normally put confidence intervals on, we're going to put the mean teach and I. There's the mean. If we want to do a standard deviation of teach and I, there it is. And if you just want to do the variance, which is standard deviation squared, you can do SD caret 2, which squares the standard deviation, or you can calculate the variance directly, your choice. Now, calculating p-values and quantiles in R, this is where we do all our p-value calculations and all our quantile calculations. You guys may have used the back of a textbook or Microsoft Excel, something like that. I don't really care. But here's how we're going to do p-values. Here's how we're going to do that. So really focus on it. There's two functions. There's always a p distribution function and a q distribution function. P calculates probabilities in the upper or lower tails. Q calculates the quantiles. So think about it this way. If you want to know a probability, you have to give me where in the distribution you are. What's the number to the corresponding distribution? If you want a quantile, you've got to tell me what the probability you're looking for is. So, a quantile. So quartiles are, first quartiles, 25th, or 0.25 quantile. All those different things. So it's something to think about, something to remember. Now, the entire idea here is I walk you through some things. What we're going to do is we're going to say lower dot tail. What that tells me is, do I need to go left of the value that I'm putting in or right of the value that I'm putting in, okay? So if I look at this, I'm going to look at a normal distribution. I'm going to say P norm 5, mean equals 1, standard deviation equals 3. So P norm 5 says lower dot tail equals false. What this says is, in a distribution, in a normal distribution, with a mean of 1 and a standard deviation of 3, I want to calculate the probability we observe the number above, any number above 5, or greater than or equal to 5, okay? Lower dot tail equals false means go above 5, okay? Now, if I just put this base in, it's going to use a z distribution, which is a normal 0, 1, and the default for lower dot tail is equal to true. So what this is going to do is it's going to find the probability I'm below a negative 2 in a normal 0, 1, okay? So if I just run both of these, you'll see the probability we're above a 5 with mean of 1, standard deviation of 3 is about 0.1, or right around 0.9, between 0.9 and 0.1, or 0.09 and 0.1. P norm negative 2 is right around 0.02, so around 2%. Now, probabilities aren't percentages, but most people don't understand that, so don't really worry about it. And I know that's hand-wavy statistics jargon. Typically, when we talk about probabilities, it's 0.02, but when you're really interpreting them for people to understand, percentages are sometimes, though it's slightly wrong, it's not completely wrong, and it won't lead them to draw the wrong conclusions, because in all honesty, guys, most people don't understand probability. Now, if you want to calculate normal quantiles, you say, look, I want to find the value in my distribution of a mean 0 and standard deviation 1 that has 0.025 probability in the upper tail. So 0.025 probability is above this value, and that's it. And it comes back and it tells you it's 1.96. I can also do it with saying 0.975 below the value. It'll give me the exact same thing, okay? So quantiles allow us to find values in the distribution. That's Q norm. Given a probability, find the value that corresponds to this. P norm says, hey, look, in a normal distribution, find the probability of being above or below this value. It's fairly easy to go, and you can do the same thing with T distributions. Just remember, T distributions have fatter tails than a normal, okay? All right, guys, let me know if you need anything.